Dear students, today we will discuss about the formula of direct and inverse proportion algebraically. First of all, we will discuss the direct proportion. If you see the expression which I have mentioned here, it is written as x is proportional to y, and when it is written in this way, then we consider it as x is directly proportional to y. It means when x is changing, y also changing, but when x is increasing, y also increasing. So when both of the quantities are increasing at the same time and both of the quantities are decreasing at the same time, this type of relation is called as direct proportion relation, right? Proportion means relation. Changes in one quantity bring changes in the other quantity. Let's have an example. If you have a vehicle and you filled fuel in it, as more as the fuel you will be having, the more distance it will be covering. So the distance is directly proportional to fuel, means the more fuel you will be having, more distance you will able to cover, right? So this is a direct relation and this we called direct proportion. All right, that on the fuel the distance is dependent, and the more fuel the more distance. And let's have another example. You have a food for some people, like when the number of people are increasing, the more food you will require. More people, more food. All right, and there are countless examples on this topic, and this is a very natural topic. You will find many examples in your daily life when two quantities are in direct relation. When one quantity is increasing, the other quantity is also increasing, right? So let's talk about this formula, this relation algebraically. So we are having x directly proportional to y. All right, it means when x is changing, y is also changing directly. When x is increasing, y is also increasing, right? So when this sign of proportionality, this is called sign of proportionality, when this sign of proportionality will be removed, an equal to sign will come and k also come. All right, everything else will remain same. What is this k called? This k is called as constant of proportionality. Constant of proportionality. It means that this is a constant. It will remain same throughout the situation. There will be a situation, there will be a scenario. In the same scenario, k's value will remain same. Let's have another example. If you took a book from the library, and the librarian asks you to bring the book tomorrow, and there's a policy in the library that if you would not be able to return the book the other day, then from the other day you will be charged fine on it. Like let's suppose one day 50 rupee means if it is one day, then you have to pay back 50 rupees in fine. All right, if it is the other day, day 2, you will be paying 100. If it is another day, you will be paying 150. So as the number of days are increasing, the amount of fine is also increasing. So this is also a kind of direct relation. So in this let's suppose that this 50 is x and this number of day is y. Let's put this example here in the formula. We will be placing at the value of x as 50 and k as it is, and at the place of y as 1. Now solve for k. So this 1 will be coming down and dividing this 50. So k will be equal to at the end as 50. Okay, let's talk about another step. Put at the place of x as, let me remove this. Alright, put at the place of x as 100 and at the place of y as 12. Alright, and solve for k. So k will remain here at the right hand side and 2 will be coming to the left hand side and will be dividing 100. So tell me, 2 1 the 2 and 2 50 the 10. Again k is 50. In the first situation also it was 50, and in the second situation also it is 50, and in the third situation also it will be 50. It means k will remain constant in a whole scenario, in a whole particular scenario for which you are solving a problem and applying this formula, right? So that's how we call it constant of proportionality. All right, I hope through this example you understood well. Okay, let's talk about this further. This is basically the formula you can apply, and in this formula, as we have already discussed, if for scenario 1 in the same situation for the same situation you have a formula, then we will call it in this way: x1 equals to k and y1, right? And for the same situation, another step is given to you. As I was telling you, for day 1 you will be charged 50 rupees as fine, and for the second day, or you can say 2 days, for 2 days you will be charged 100 rupees for 2 days, and for 3 days you will be charged 150 rupees, and for 4 days you will be charged 200, and so on. So this is related to, you can say, scenario 1, that for day 1 you will be charged 50 rupees. All right, and in the same situation we will write x2 equals to k y2. All right, so this is for 1 day, and this is for 2 days, you can consider, or for 3 days, or for 4 days. Let's talk about k. If we bring y to the left hand side, it will become x1 upon y1 equals to k. All right, and in the second scenario also, if we bring y2 on the other hand, it will become x2 upon y2 equals to k. All right, in both of the scenario, in the same situation, you see that x1 upon y1 is also equals to k, and x2 upon y2 is also equals to k. So hence for this discussion, or can we say that x1 over y1 equals to x2 over y2. So hence this is the formula which we will use for different situations, the situations of direct proportion, when one quantity will be related to another quantity in direct relation. In direct proportion means when one quantity is increasing, the other quantity is also increasing. It will be you who will decide, and by analyzing the situation, that are the two quantities in direct relation or not. Thank you. For then this formula will be applied. All right, and the other way of writing this formula is this also. You can bring this y1 to the left hand side, and this y2 to the left hand side, and y1 to the right hand side. All right, and this will be written in this way. This is y1.